In this lesson, we're going to solve trig equations, just like you solved algebra equations, except now your goal is to isolate the trig functions. So in this problem, we want to get sine x completely by itself before we can do anything else. So same rules of equality, add 1 to both sides. 2 sine x equals 1. I'm going to divide both sides by 2. So now I've got sine x equals 1/2. And now here's your question. Where does sine x equal 1/2? Alright. If you look at your unit circle, you'll see where does sine x equal 1/2. You'll have to remember that sines are the y-coordinate. So we're looking at y-coordinates. There's a 1/2. So at pi over 6. Does that happen anywhere else? Going around the circle. Okay, it happens at pi over 6 and at 5 pi over 6. Okay, we have to write these as all solutions. So when I write pi over 6, I'm also going to add on how often it repeats. Every 2 pi k. And then my other answer is going to be 5 pi over 6, and it repeats every 2 pi k. And then you're done. Okay, try solving this one. It's just like the first one. First thing I'm going to do is add 1 to both sides. 2 cosine x equals 1. Divide both sides by 2. Cosine x equals 1/2. So where on my unit circle does cosine equal 1/2? Alright, so if I move this up, I can see the whole unit circle. Cosine's my x-coordinate. Where's my x-coordinate? 1/2. It's going to happen right here at pi over 3. And x-coordinate 1/2 would also be right here at 5 pi over 3. So you've got two answers. X equals pi over 3 plus 2 pi k. And you've got x equals 5 pi over 3 plus 2 pi k. Okay, we're going to go through different strategies on solving. This was going to be combining like terms. I've got sine terms on both sides of my equal sign. I'm going to bring this one over and move my -2 over to that side. It really doesn't matter which side you go for. So if I add sine x on the right, I've got to add it on the left. So now I've got 2 sine x plus radical 2 equals 0. If I subtract my radical 2, now I've got 2 sine x equals negative radical 2. And if I divide both sides by 2, now I have sine x equals negative radical 2 over 2. So we pull up the unit circle, and we look to see where does my y-coordinate equal negative radical 2 over 2. Sine is negative in quadrant, let's see, it's positive in 1, positive in 2, so it's going to be in these two quadrants. And I'm going to see it right here at 5 pi over 4 and over here at 7 pi over 4. So my answer, x equals 5 pi over 4 plus 2 pi k. X equals 7 pi over 4 plus 2 pi k. And another problem for you to try on your own. This is supposed to say Alright, this is supposed to be a sine x, where that x is. So your problem is sine x plus radical 2 equals negative sine x. So solve that one. I'm going to add my sine x. So I'm going to have 2 sine x plus radical 2 equals 0. Subtract my radical 2. 2 sine x equals negative radical 2. Divide both sides by 2. Sine x equals negative radical 2 over 2. Is going to be the same answers we had in the last problem, which is going to be x equals 5 pi over 4 plus 2 pi k, and x equals 7 pi over 4 plus 2 pi k. Solving an equation that has a square in it, start off the same way. Add 1, 3, tangent squared x equals 1. Divide both sides by 3. So now tangent squared x equals 1/3. How do you get rid of a square? You're going to square root the right side. So I'm going to add tangent x equals, plus or minus when you take the square root, square root of 1/3. Now think about your simplifying square roots. This is going to be plus or minus 1 over radical 3, because we make this radical 1 over radical 3, and radical 1 is 1. And then if I want to rationalize it, I can, but I think it's easier to see if you leave it like this. Okay, if we check out the unit circle, tangent, remember, is our y-coordinate divided by our x-coordinate. So, and it's going to be in all 4 quadrants because it's a plus or minus. Okay, so if I take this one, see if we can get close, it does have the radical 3. And I think of y-coordinate of 1/2 times the reciprocal of the x-coordinate. That's exactly what I want. So I'm going to get all the pi over 6's in each quadrant. Okay, now what's this look like when you write it out? You really only have to write 2 answers, because I can write x equals pi over 6 plus pi to get to the next one, plus pi to get back. So I can just list it as pi over 6 plus pi k. And then same with the other one, I can do 5 pi over 6 plus pi k. So when they are in quadrants that are across from each other, you can shorten it to pi k, and you now included both of these. Okay, try to square with a sign. See if you can get the right answer. I'm going to add 3 to both sides. So this is 4 sine squared to the 4th equals 3. Divide both sides by 4. So now sine squared x equals 3/4. Taking the square root, now I'm going to have sine x equals plus or minus radical 3 over 2. Square root of 4 is 2. Where is that on the unit circle? You should have yours out so you can be looking at it. Sine is my y-coordinate. Where is my y-coordinate? Radical 3 over 2. That happens first at pi over 3. It's going to happen in all 4 quadrants, so I'm going to do pi k to include quadrant 3. And it also happens at 2 pi over 3 plus pi k to include the angle in quadrant 4 as well. Okay, let's talk about factoring to solve. First, if you have multiple terms that cannot be combined, you want to get them to one side. So I'm going to subtract my 2 cotangent x. So now I have cotangent x, cosine squared x minus 2 cotangent x. They both have a cotangent in common, so I'm going to factor that out. So cotangent x times cosine squared x minus 2, and this equation does equal 0 since we took everything from the right side. Now I've got 2 to solve. I've got to solve cotangent x equals 0, and I've got to solve cosine squared x minus 2 equals 0. Cotangent x equals 0 is already solved for. Cosine squared x minus 2, I need to add 2. Cosine squared x equals 2. Get rid of the square. Now cosine x equals plus or minus radical 2. It might, well, we'll see what it looks like on the unit circle. Okay, for cotangent. For cotangent, I want to find where it equals 0. Since tangent is y over x, cotangent is going to be x over y. So I'm looking at my axis coordinates. When I take my x over my y, which one's going to give me 0? That's going to happen at pi over 2 and 3 pi over 2. They are pi apart, so they can be combined into one statement. So the answer to that one is going to be x equals pi over 2 plus pi k. Where does cosine equal radical 2? Well, let's see. We're not going to find it on the unit circle. Let's think about what radical 2 is. In the calculator, if you punch in square root 2, you're going to get a plus or minus 1.414. What do we know about the cosine graph? We know that it looks like a bowl. It goes up to 1, down to negative 1. Where is it ever going to reach 1.4? It's never going to reach that. So we don't solve that. Our only solution is the one that came from the tangent side. Okay, try this one factoring, see if you can get it. Get it all to one side. So then I'm going to have sine squared x minus 2 sine x equals 0. What do they have in common? Sine x. Left over sine x minus 2 equals 0. So now I've got two equations. Where does sine x equal 0? Sine x minus 2 equals 0 solves to sine x equals 2. You should realize that this is never going to happen. Sine only goes from negative 1 to 1. So this is the only one I need to worry about. Where does sine equal 0? Zeros, I like to think of the graph. It's at all these spots right here. So it's happening at pi. It's happening at 2 pi. It's going to happen at every pi k. So x equals pi k.